Welcome to this introductory course on the optimization. Now, in this series, we will explore the fundamentals of the optimization. Over the next few videos, I will cover why optimization is essential. Why do we need the optimization? We'll also cover where optimization fits into the AIML space and how it is different from the AIML. We'll also cover where it is applied in the business world. Next, we will take what is the optimization, the basic optimization framework, and we will discuss common tools used to solve optimization problem, including both open source and the commercial solver. We'll also work through some hands-on exercise in Excel and then dive into Python to solve a few sample optimization problem. So let's get started. Now, why optimization? Imagine that you are working in an FMCG business and you are holding a large amount of the inventory. This is reducing your profit margins and tying up capital. Now, your boss has asked for suggestion to reduce the inventory and free up some cash. One of your colleagues suggests simply selling more to the customer. While that's the goal, the inventory isn't moving as expected. So your boss tells, go and feel free to tell this idea to the board that it's your idea. Now, this is very common business challenge of inventory optimization. And the key question is, how do you determine the right amount of inventory to maintain? That's where the optimization comes into the play, helping you find the ideal inventory level to balance cost, demand, and capital efficiency. So again, why do we need the optimization? So let's look at why optimization is important in a more formal way. The first reason is there are too many options. Imagine you need to visit the capital city of every state in India at the lowest cost. What route should you take? With 29 cities and multiple transportation options between them, the number of possible routes quickly becomes overwhelming to calculate manually. This is why optimization helps find the best solution efficiently. The next, the complexity of the problem. Sometimes the problem is too complex to solve by hand. For example, in production planning and scheduling, you may have hundreds of material with different consumption rates, the chemical properties. Manually figuring out the optimal production schedule is nearly impossible. The next, lack of information or the lack of decision-making power. Now, optimization is also needed when decision maker don't have complete information. For instance, in a refinery, the yield from production depends on the parameter like crude properties, the reactor temperature, pressure in a reactor. The person operating the machines may not know all the decision that is needed to optimize the yield along with the time. So this is a continuous process and they have to keep updating these parameters to get the best yield from the operations. So that's where the optimization model comes in. The next, human biases. People can be biased towards certain decisions. Let's take an investment portfolio optimization as an example. Without optimization, decision might be biased by personal preference rather than the best financial strategies. But the algorithms would be 100% driven by the objective. So now we have discussed about why we need the optimization. So let's discuss the real world applications of the optimizations. The optimization plays a crucial role in various industries, and I'll give you few examples only, but this is not all the exclusive list. So let's take the production planning and scheduling of the materials. In any manufacturing unit, the optimization helps plan production for multiple products with different demand based on maybe the day or week level. For example, If you are producing 10 types of the biscuits, each require different raw materials, for example, different quantity of the sugar, sweetness, uh, and some other materials. They also requires the different manufacturing processes and the equipments. They have the different run rates. So all the different products varies depending on the properties, quality, and type of the biscuits. Now, optimization help efficiently schedule production to meet the demand while also minimizing the total cost and downtime of the plant, such as when you're switching productions from one product to another product, you will have to clean the equipments, so that's called the changeover. So it also minimizes the downtime as well as the manufacturing cost. Next, we can take as an for the warehousing and the facility locations. The companies use the optimization to determine the best location for the warehouses and new production facilities. This ensures that logistic and the transportation costs are minimum while meeting the customer demand efficiently. Next example that we can take is the e-commerce, optimal routing for the e-commerce. The e-commerce companies such as Flipkart, Amazon, and many more uses the optimization to find the best delivery routes, reducing the transportation cost and ensuring the timely delivery of the products. Now, these are just a few examples, but optimization is applied across wide range of industries from supply chain management to the finance, and almost every industry has a use case for the optimization. Since we have discussed the use cases of the optimization, now let's also discuss where optimization fits in the analytics space. So optimization is part of the broader analytics space, and we can broken down the analytics space into the four main categories. The first being the descriptive or the basic reporting. Now, the descriptive analytics tells us what happened. It focuses on summarizing the historical data to understand the trends and the pattern. For example, the sales reports, revenue summaries, the customer behavior, dashboards, all falls under the descriptive analytics. Now, and when we look at these analytics in respect to the input, the business context, and the relationship between the person who is working on it versus the business context, and what's the result of that. In the descriptive analytics, we know the input, the historical data. The business context is with the person who is working, so that's manual analysis. The relationship between the input and the business context is also manual. And what is the impact of the descriptive analytics is the focus, finding out the impact and the result. Next is the diagnostic analytics. This analytics explains why something happened. It goes deeper than the descriptive analytics by identifying the causes and the correlation. For instance, if sales drops in a retail chain, the diagnostic analytics helps pinpoint the reason, like why sales dropped. Is it because of the seasonal trend? Is it because some supply chain disruption, or because of the customer preference? So in diagnostic, we focuses on why something happened, right? So the manual interaction is between the relationship of the input and the business context. And the non-element is we know what has happened, what is the impact, like the sales has dropped, that's the impact, right? And we try to find out the reasons, recommendations. So that's the manual. The next is the predictive analytics. This analytics helps you understand what might happen in the future. It helps in finding out or predicting in the future what would happen. So it uses the historical data and machine learning algorithms to forecast the future outcomes. For example, what would be the sales in the next coming months based on the previous seasonality, trends, or the external factor like the market conditions. So the focus remain on finding out the recommendations. The next comes the prescriptive analytics. This analytics focuses on what action to take to achieve the best outcome, such as minimizing the total cost, maximizing the efficiency, and it could be maximizing the profit margin, and this is where the optimization fits in. The prescriptive analytics not only predict the future outcome but also recommend the best course of action to achieve a specific goal. So in the prescriptive analytics, we know the input, we know the business context is modeled as a constraints and the objective functions, and the relationship between the objective functions and the input is also modeled, and the focus is only on the recommendations. So the prescriptive analytics gives us what actions to take. Now, to summarize the different categories of the analytics, the descriptive looks at the past data to understand what happened. The diagnostic always, why things happened by finding the patterns and the correlations between the data. The predictive gives us the forecast future outcomes based on the historical data, and the prescriptive gives us the best action to take using the optimization that will help achieving the business outcomes. So in this video, we have discussed about why optimization and where it is placed in analytics space. In the next video, we will focus on what's the optimization, what's the basic framework of the optimization, and then we will see the couple of examples using the Excel and the Python. Thank you.